Okay, so this video is going to look at the cumulative frequency distribution called a CDF, and it works in with 1403 from the Margaret Gove textbook, which is the exercises are in your OneNote. Okay, so remember we're looking at PDFs. Okay, we've been looking at PDFs and we've been looking at continuous PDFs, and the area under the curve of a continuous PDF is 1. What we're going to have a look at today is the cumulative distribution is the general formula for finding the probability of x is less than or equal to x. So we're going to basically be looking at a general form of the PDF for continuous functions. So we're going to say that big F of x is the integral between x and a of our function with respect to x in the domain a to b. Now what we're going to do is pop a as our lower value, and the x stands for any value of x within that domain a to b. And we don't know what that's going to be, and that's going to help us give us a general formula that we can use to figure out the area under the curve. So this is looking at cumulative distributions. So we're going to go and we're going to get a type of continuous PDF, and it's going to be called a CDF, or a cumulative probability distribution. So let's look at the example and see if we can get it to make sense. So a continuous probability function. So it is a PDF, okay? So the area under that curve between 1 and 4 is going to be 1. Here's our function. It says find the cumulative distribution function. This is our generic formula. Once we have our generic formula, we can substitute in our values to work out what our probabilities are going to be. So for part A, let's find the CDF. So f of x is the integral between x of a of our function. Okay, so our smallest number in our domain is 1. It goes to the bottom, x goes at the top. Our function goes in here. We're going to integrate that function with respect to x. Pause the video and have a go. What you're going to do is we're going to add 1 to the value, divide by the value. The 4's will cancel, and we've got x to the 4 on 255, and we've got x and 1 as our upper and lower bounds. Pop in x, and we've got what we've got up there anyway. Take away what we get, and we pop in 1, which will be 1 to the 4 on 255. Simplified, here's our CDF, okay? X to the 4 minus 1 on 255. And this finds probabilities, a probability value less than or equal to x. If this inequality goes the other way, we're going to have to do a little change. Okay, so what we can now do is use this CDF we've just found to calculate 1 and 2 up here. So part 1 says find the probability of x being less than or equal to 3. All we do is substitute in our 3 into our function, and we end up with this value here. Now, if you didn't work out your CDF to start with, you could have done this from last time's lesson, okay? We're going to integrate our function between 3 and 1, and you would have got the same answer. So you've got options now basically to work it out. For the second one, we're going to pop 1.6 in that first equation for our CDF, and it's going to give us the probability of 0.0218. Okay. Or, using last time's work, you could have integrated your function between 1.6 and 1, and you would have got the same answer. So we haven't really learned anything new. We've just looked at a generic form of an equation there. Okay, we're now going to have a look at the mode. Now, the mode is the most popular or the most common. That's how we used it in our data topic earlier on, and when you did that in your junior years. And it's still the most popular. In CDS, it's the maximum point on the curve. So if you have a function, the highest point, the x value that relates back to that is going to be your mode. Now, and I might just quickly jump over and show you some of those in here. So if you've got graphs like this one in our exercise, what you'll find in any of these functions here, the mode is going to be the highest point. Here's our highest point. The number that matches that highest point there is 2. So our 2 would be the mode, and that would be the same for any of them. Okay, over here, our highest point sits up here. The number that matches that is 7. 7 is our mode. So that's fairly straightforward, but what if we don't have a graph? If we don't have a graph, we need to think back to calculus. So let's read the example on your notes here. A continuous probability distribution is to find on the interval 1 is less than x, 1 is less than or equal to x is less than or equal to 5. And it has this equation here, and it says finding the mode. So if you look at that equation, if I was expanding this top line out, I'm going to get a negative x squared in there. So I'm going to have some form of a parabola. It's going to probably be a very flat parabola. And what we're going to end up with is something that probably looks a little bit like this, between 1 and 5. But we don't have the graph. We need to think about what happens. So to find the mode, we want the highest point on the graph. So in our parabola, or in any graph, the highest point on a function is where we have a turning point, and that is where our first derivative is equal to 0, where the gradient of our tangent is 0. So that's what we need to do over here. We need to find our stationary point, and that's where our f dash of x is equal to 0. Now, you've got options for this, and you might want to pause this and have a go yourself. So you can use the product rule. I would not use the product rule. I would expand out and then pop each term over 92. So I end up with 18x on 92 minus 3x squared on 92. You're not needing to use the product rule. That just makes it a little bit easier for you. So f dash of x is 18 on 92 minus 6x on 92. The stationary points happen when the first derivative is equal to 0. So if I just set this to 0 here, before I go and quickly rearrange it, I've got 18 on 92 minus 16 on 92. So for them to be equal to 0, these must be the same. The bottom lines are the same, so my top needs to be the same. 6 times what is 18? 3. So if you can see that, that saved us a lot of time. So our mode could be 3. It's going to be 3, but I actually would prefer it if you proved that it actually was 3. Because what if we had a curve, and I'll just draw another diagram over here, where we had two things like this. What if we ended up with two parts that could have come back as a mode? Or the number that we got, what if it was a minimum value? So we need to be really careful and actually show that this point of x equals 3 actually is going to be the maximum. And we can do that with our second derivative. So let's find our second derivative. Okay, so we've got our first one and we'll differentiate that again. If I differentiate this, the first part goes to 0. My second part goes to minus 6 on 92, which is a value, which is a negative number. So that is always less than 0. Less than 0 is negative. There's our sad negative face. It's a maximum. So therefore the mode is 3. We've shown it's a maximum. So I'd actually like you to show on those that it is the case. HSC markers will like that, and they may be allocating marks for that. So that's 1403.